11.5. The normal distribution. Distributions of mileages of different sample sizes of cars are shown below. As the sample size increases, the distributions become more and more symmetrical and resemble the curve at the right, and that's due to the law of large numbers. The curve at the right, the furthest to the right, is considered a normal distribution. It's continuous, symmetric, and it has this bell-shaped curve. And that's the distribution of a random variable. It's the most common continuous probability distribution. The curve is continuous, like we said, bell-shaped. It sort of looks like, like the Liberty Bell. And it's symmetric with respect to the mean. And that really means that the center should be the mean value. The mean, the median, and the mode are equal and are located at the center in a perfect normal distribution. And the curve approaches but never actually touches the x-axis. The total area under the curve is considered equal to 1, or if we're thinking percentages, 100%. So literally when we're saying area, that's exactly what we mean. Like if you're thinking about a rectangle, like length times width, we mean literally area. That's all this blue space. It's going to add up to 100%. So the area under a normal curve is representing the amount of data within a certain interval, or the probability that a random data value is going to fall within that interval. We have something called the empirical rule, and it's used to determine the area under that normal curve at specific intervals. And when we're saying intervals, what we mean is moving certain numbers of standard deviations away from the mean, away from the center. So remember that lowercase sigma stands for standard deviation, kind of the O with the circle extended. If we were to start at the mean, and this letter, this is called mu, this just means mean. Instead of x bar, we can use mu. It almost looks sort of like a M, like a cross between a U and an M. So this right here is the center. This is the mean of our data, the mean value. If I were to move one standard deviation to the right, whatever that distance is, and one standard deviation to the left, the space between those two endpoints is going to be 68%. So in here is 68%. If I were to move two standard deviations away from the mean, so 2 to the right and 2 to the left, from those endpoints, all of this space is going to be 95%. And if I were to move 3 standard deviations away, I'm going to be at 99.7%, which is almost everything. So what we're given here is the mean and the standard deviation, and we are told our curve has a normal distribution. So the best thing you can do in these types of problems is to try your best to draw a bell curve. It's not terrible. All right, so in the middle is whatever our mean value is. So our mean here is 21, okay? Our standard deviation is 4, and we want to find the range of values that represent the middle 68. That means one standard deviation away in both directions. So we want to move one standard deviation to the right and one standard deviation to the left, and that space in here is going to be 68%. So the standard deviation is 4. We're going to go up 4. So that's going to give us 21 plus 4, or 25. And we're going to go down 4. So 21 minus 4. So that's going to give us 17. So that means that our range of data is between 17 and 25. What percent of the data will be greater than 29? Okay, so what we want to do here is just kind of continue to count how many standard deviations away and keep adding or subtracting. So we have our mean in the middle, we said was 21. If we went one to the left and one to the right, that's going to give us 17 and 25. If we go another to the right, another 4 spaces, that's 29. That would be 13. And we could keep going, but we know from here to here is 68%. We know from here to here is what percentage? We are at 95%, right, from here to here. We want to know what percent of the data is greater than 29. So we want to know how much is over here. Okay. Well, there's a few ways that we could go about doing this. Probably the easiest way is to recognize that we have right now 95% of the data in this section. Okay, 95%. So we have that blue section on the left and we have the green section on the right. Or sorry, the blue on the right, the green on the left. The blue is what we are trying to find. Okay. If we know the red is 95 and the whole thing, the red, the green, the blue, all of it has to add up to 100%, we only have 5% to spare between the green and the blue. So if I take that leftover 5% and cut it in half, that means that there's 2.5% over here in the green and 2.5% over here in the blue. Altogether, that adds up to 100%. Our question is, what's greater than 29? That's going to be this blue part, so 2.5%. All right. Let's take a look. Same type of question here. So we have a normal distribution. Our mean is 8.2. And our standard deviation is 1.3. What's the middle? 95%. That's 2 standard deviations in both directions. 1, 2, 1, 2. So we want to go up 1.3. So if we add 1.3, that's going to give us 9.5. If we do that again, that's going to give us 10.8. All right. How about if we subtract? So 8.2 minus 1.3 is going to give us 6.9. And then if we subtract it again, that's going to give us 5.6. And 95% is those 2, 1, 2, 1, 2 standard deviations away. So all of this is 95%. That's between 5.6 and 10.8. All right, what percent is going to be less than 4.3? So let's count this one more time. If we take this and go one more standard deviation to the right and to the left, let's see, 1.3, that's going to give us 12.1. To the left, that's going to give us 4.3. We want to know what's less than 4.3. So that's going to be this little space in here. Okay. 2 standard deviations away was 95%. 3 standard deviations away is 99.7%. That means I only have 0.3 to spare between the red and we can color it in this green space over here. So half of 0.3 is going to be 0.15. Or sorry, yeah, 0.15. Okay, so that means less than 4.3 is going to be 0.15%. Very little of this data is going to be less than 0.15%. All right. The heights of 1,800 adults are normally distributed with a mean of 70 and a standard deviation of 2 inches. About how many adults are between 66 and 74? So here's our bell curve. We said it's normal. That's why we're drawing the bell curve. The mean is 70. So right in the middle, we're going to be at 70. And let's just count off our standard deviations. So 2 inches, 2 inches. So that would be 68 and 72. That's 1 standard deviation away. A second standard deviation, minus 2, plus 2. Okay, so about how many adults? Well, we see that this is going to be 2 standard deviations away. That means that 95% of the data is in here. That means 95% of the 1,800 adults are going to be between 66 and 74. So 95% of, that just means multiply. So 0.95 times 1,800, and that's going to give us 1,710 adults. All right. What's the probability that a random adult is more than 72 inches? All right, so if we go back, let's just kind of copy this over real quick. We don't need all of this. 1 standard deviation away is 72, 68. Okay, so from here to here, 1 standard deviation is 68%. How many are more than 72? So I want all of this space over here. 68's the middle. I also have all of this on the left. So if we do 100 minus 68%, that's going to tell us that we have 32% to spare. And that's between here and here. So that means that there's 16% over here. And there's 16% over here. All together, that will add up to 100%. So we have a probability of 16% of our adults will be more than 72 inches tall. All right. The number of friends per member in a sample of 120 members is normally distributed. Immediately draw that bell curve. With a mean of 39, that's the middle, and a standard deviation of 12. All right, so count up 12, down 12. So when we add 12, that's going to give us 51. When we subtract, 51. And when we oh, I'm sorry, this is a typo. I apologize. I was going to say that doesn't sound right. I'm sorry, this should have said 38, not 39. That is my bad. Sorry, 38. Okay, so if 38 is our middle, when we add 12, that makes more sense. There's 50. When we subtract 12, that is going to give us, that's going to give us 26. Okay, so we want one standard deviation away. That's 68% of our data in the middle. 68% of 820 is going to give us the number of members. So that's 0.68 times 820. And when I do 0.68 times 820, we're going to get, that's about 550. I got 557.6, but we're talking about people, so we'll round up to the nearest whole. So 558 members. All right, what's the probability that a random member will have more than 14 friends? All right, so let's keep counting. We said the center was 38. If we go up and down, that's 50 and 26. If we go up again, that's going to be 62. Down again is going to be 14. All right, more than 14 friends. Well, we know from here to here, 2 standard deviations is 95%. Now, if we want more than 14, we want all the red, well, now blue, and all of this space over here. Well, if that's 95% there, we have to split the other 5% between here and here. So this is 2.5, and this is 2.5. And if we want it to be greater than 14, that's all of this side. So 95% plus 2.5% is going to give us 97.5%.